If you've got a touchscreen for your Arduino, you're going to need to know how to calibrate it and then how to turn its values into screen pixel coordinates. So let's see how it's done. Hi and welcome to Bytes and Bits. We've been doing quite a bit of work with our LCD touchscreen panel, and today we're going to have a look at how we can actually set up the touch part of it. So we're going to have a look at how we calibrate our resistive touchscreen and get that all set up. So let's start by having a think about how the resistive touchscreen works and how we're going to then calibrate that. A resistive touchscreen is made from two layers of conductive material, and these are separated by a very thin layer of non-conducting material, either sort of a gas or a liquid. And basically, when you press your stylus against the screen, you make the two layers touch. Because the layers only have to touch, this is why you can use whatever you want to activate your touchscreen. So it doesn't have to be a finger, it can be a stylus or whatever. But it also then means that you have to press slightly harder on a resistive touchscreen than on a capacitive touchscreen. So once the layers have touched, the system is basically able to form a potential divider between opposite edges of the screen. So looking at that horizontally, we can see that we have a touch point and then a potential divider which lets us measure in effect a voltage at where we touched it. And then we can repeat that process for the vertical direction, and we'll get then two values for the point at which we touched. Because the touchscreen and the LCD circuitry aren't connected in any way, we now have to translate the values we're getting back from our touchscreen and match those up with the pixel dimensions on our LCD screen. So this is what we call the process of calibration. Now, because the touchscreen's zero position won't necessarily, and actually it won't match up with the zero position on our screen, we can't just do one point, we have to take multiple points. Now, the most accurate way is to take 3 points, because this lets you both calibrate the position of your point on the touchscreen, but also lets you calibrate the misalignment of the touchscreen, because the way in which the two layers are put together, both the LCD screen and the touchscreen, they might not exactly line up horizontally or vertically. So taking 3 points lets you factor that value in as well, but it does involve quite complex mathematics. And on these small screens, the actual alignment error is going to be rather small, and in effect the error where you're touching your point on the screen is probably going to give a bigger error than the alignment. So I'm going to just use 2 points, which lets us then actually work out the mathematics ourselves without too much bother. And so we can actually do our own calibration code. If you do want to do full 3-point calibration code, your probably best bet is to download a package which lets you do that. And some of the touchscreen packages then have that built in. But we'll say we're going to do this by ourselves, so we can learn both a bit more about coding and a bit more how these things work. So we'll just use a simple 2 points as shown on the screen. So in effect, we're going to end up then at the end of our calibration routine, we will have 2 points where we know what the pixel dimensions of that point were, and then we will have measured the touchscreen resistive values for that as well. So we now need to work out a way of mapping the values we get back from our touchscreen with the pixel dimensions on our LCD screen. And really what we can do here is we can assume that we have a linear relationship. So if we were to plot these on a graph, so let's think about our x coordinates. So we're going to have to do our x coordinates and our y coordinates separately. So if we were plotting a graph, we could plot a graph of the actual pixel value on our vertical axis and then the value returned from our touchscreen on the horizontal axis. And we can then plot the 2 points that we've measured so far, so our top left point and our bottom right point. And that will then give us 2 points on our graph, and we can then put a straight line between these. And we'll see that the line doesn't go through the origin of our graph. So that shows then that the 0 position in our pixel LCD screen won't necessarily match up with the 0 position in our touchscreen values. So we need to model this then as a straight line. So we think about our normal straight line equation. So our y value here is actually our x pixel value. So that's going to be equal to some gradient of this line times our x value coming out of our touchscreen plus this constant c, which again signifies the y-axis crossing point. So what we have to do now is really just get some formulas which will let us work out these values for m and c, and that will then give us our straight line equation for this particular x-axis. We can then repeat the whole process for our y-axis, and that will end up then giving us two equations which will let us then translate the values we get back from our touchscreen into pixel dimensions on our LCD screen. So let's go and have a look at actually coding that and see if it works. So this Arduino sketch will take us through the calibration function and then allow us to check that out by letting us move a little block around the screen. So as we touch the screen, this block will follow us around. So to begin with then, we're very much using the same basic setup that we've been using in the previous animation tutorial and the setup tutorial. So if you haven't been through the setup tutorial, please do go and have a look at that, which will show you how to get the screen all connected up so that we can both draw on the LCD and read from the touchscreen. So we're using the same sort of libraries. So again, we're using the Adafruit graphics libraries and LCD screen driver, and then this XPT2046 touchscreen driver, which will let us then talk to the little chip. So my touchscreen, my resistive touchscreen uses this XPT2046 chip. So once we've got all that set up, so we've got set up here, and if I scroll down the bottom here, you'll see that in our setup function, again, this is exactly the same as we do with our normal work for the animation and so on. The only addition here is that we, at the end of our setup function, after we've turned it black and set up the rotation and initialized our various variables, that just simply calls the calibrate touchscreen function, which we're going to have a look at in a second. So we also then, once we get past the calibration, then we have a bit of code in here which will let us then just simply check if it's being touched and let us draw a block. But again, we'll come to that in a second. So let's first of all have a look at this calibration function. So this is called at the end of our setup. So at this point, we now have our LCD screen set up and our touchscreen set up, and we create up here, we create two global variables. So TFT is an instance of the Adafruit ILI9341 driver object. So again, that's what we use to connect and talk to the LCD screen. And then TS is an instance of this touchscreen object. And again, that's what lets us talk to the actual touchscreen circuitry. So once we calibrate, we know that we're trying to find out values which let us calibrate the X and Y values. So we've seen that we need to model those as linear equations. So we need to have both an X gradient and a Y gradient and an X Y-axis crossing point and a Y-axis crossing point. So we're going to store the values of those two modeling lines inside these variables. And again, I'm making them float so that we can just get a little bit of extra accuracy on those. And some variables here I'm defining which are going to be doing with the displaying of the blocks, use the block size and block position. I'm then going to just use a little bit of extra code to make it easier for us to work with our screen coordinates and so on. So we know that the screen coordinates are made up of X and Y values. So I'm just creating a little class here called a screen point, which just wraps up those X and Y values inside a little object. And that makes it easier for us to handle them. And when we get on to creating our breakout clone game, which will be in the next video lesson, then that makes the whole process easier. So we do have a function here which will do the actual translation at the very end. So we'll come back to that after we've done the calibration. So in our calibration function then, we're going to need to be able to talk to the touchscreen and get back the position of the current touch. So when we touch it, we'll be able to sense that, and we'll then be able to ask the touchscreen, give me back those potential divider values from that particular touch point. And then we're going to need to store those values, so it returns back two integer values, so an x integer value and a y integer value, and we're going to do that for 2 points, so we'll end up with our x1, y1, x2, y2 as our two touch points that come from our calibration function. So we'll start by just blanking the screen, by just filling it black. Then the person might be touching the screen as they turn on the Arduino. So we're going to do a little loop here. So we're saying here, so if the touch screen is currently being touched, then we'll just stay inside this loop until it's stopped being touched. And that saves us getting a false reading at the very beginning of our calibration code. So once we've detected that nobody is touching the screen, then we're going to draw a little red cross. And that red cross is going to be centered at pixel coordinates 2020. We then sit there, so that tells the person where they need to touch. And we're then going to wait until the screen is touched. So while it's not being touched, sit in this loop. We're then going to do a little slight delay here. And what you find is when you first bring the stylus down to touch the screen, the very first touch that is recognized by the screen, those coordinates are slightly different from when the actual person has finished pressing it against the screen. So it's almost like as it touches, it sort of half touches and gets a slightly erroneous value. Now that when we get through to actually using the touch screen, that's not such an issue. But when we're calibrating it, it can throw out our calibrations. So I've just put in a little 50 millisecond delay here to make sure that the stylus is firmly pressed against the actual screen. So once we've got the stylus in the right position, we're then going to call this method. So remember, TS is the object that is linked to our library software for the touchscreen, and that then has a method called getPoint. So that will return us back one of these TS point objects. So again, I'm capturing that in my variable P. Remember, we made that into one of the TS point variables. So that will then give us back, so P.X and P.Y, those will be the two raw readings from our touchscreen. And you can see there, we're just simply saving them into X1 and Y1. We're then going to overdraw that red cross to take it off the screen. We're then waiting for half a second, and we're waiting for the person to then lift the stylus off the screen. So again, so at the moment, so just in here, this is where the person has touched on that first X. We've then removed the X, and we're now going to wait for them to lift the stylus off. So while our touch screen is touched, we just simply sit here. So once we break out of that loop, that means that nobody's touching the screen anymore. So we're going to draw another red cross, and that's going to be centered 20 pixels in and 20 pixels up from the bottom right hand corner of our screen. So again, we're using our tft.width function here. So that will tell us how many pixels wide the screen is, how many pixels high the screen is, and we'll just draw a little red cross centered 20 pixels in and 20 pixels up. And then we just simply repeat that same sort of process. So we wait until the screen is touched, then we let that touch settle down to get an accurate reading, and we then make a log of those two X and Y coordinates. Then we delete our black our little red cross, and then we go into the actual calculation portion of our code. So we saw from our initial discussion that we need to calculate a gradient and a y-axis crossing point for both our x values and our y values. So this is where we're just sort of calculating that. So we need to know the difference between our two X pixel positions. So in our X direction, that's really just the width of the screen minus 40 pixels. And in our Y direction, that's the height of the screen minus 40 pixels. And then to calculate our gradient then, we use this pixel value difference divided by our touchscreen X values difference. And that will then give us our gradient. And then we can substitute those values into one of the points that we measured. So I'm substituting it into our x1 point here. And you can see how we're calculating then this c. So we have an m and a c then for our x coordinate. And then we do the same again then for our y coordinates. So we end up with an m and a c for our y coordinates. And those then are stored. So this xcal m, xcal c, and so on, those are global variables that are defined up the top of the code here. And they'll then be used in the actual calculations. And all that's happening here is I was just doing some debugging where that's going to put out in the serial channel so we can see what the calculations came up with. So that is the calibration stuff. So we now have an X model and a Y model to translate the raw values coming from our touchscreen into actual pixel dimensions. And I've created then a little function up here. So once we've run the calibrate touchscreen function, our xcal m and so on, those are now loaded with the correct values to model this. And really all we're doing is we are sending in an X and a Y value, and those are going to be values which we've read straight from the touchscreen using that library software. And this bit of code then is simply going to take that. You can see here that it's using our X times, so mx plus c, and our mx plus c here as well. So we're doing the calculation and we're then rounding it to the nearest whole pixel value. And that then gives us an idea of where we are, and then just a little bit of error checking here. So if the values that we calculate are less than 0, well, we can't have a pixel value less than 0, so we're just limiting it to 0. And same at the other side there, it can't be more than the width of the screen minus 1 pixel. So we just limit those two values just in case something went off the edge of the screen, and then we return one of these screen point objects. So we create a screen point object, load it with the X and Y coordinates. So those are now the pixel coordinates, and return that back to our function. So down here then, we'll see where that's actually used. Okay, so we have this idea. So in our main loop, we're looping around here 50 times a second. Again, we're using this frame timer stuff here. And again, have a look in the previous animation tutorial to see why we need that and how we do that. Basically saying if somebody is touching the screen, then we're going to move the block, and that's really going to move the block to where that screen is being touched. So inside here then, we're basically setting things up. We're just rechecking that it is actually a touch. We're then reading the values from the touch screen. We're then getting hold of those values and passing it across to our little function that will translate the touchscreen values. Remember, so these two values here are the touchscreen values, and this function getScreenCoords will translate those into screen coordinates and return them back as one of these screen point objects. And once we've got that, we can then simply just work out where we need to draw our rectangle. So we do that. So again, we're doing this here. So we're saying the new position of the rectangle. We calculate all of that. We have a look to see if the rectangle is actually moved from its previous position. And if it has, then we delete the old copy of the rectangle and then draw the new copy of the rectangle. And that will just simply then give us our rectangle moving around the screen with our stylus. So that's really the code then. I'll say that the main part of it is this calibration function. So we come through here, we do our calibration, we calculate our gradient and our crossing points for both X and Y, and then we embed those into a little function. And you can see here, so it's a very simple function really, and it just uses that straight line equation to translate touchscreen values to pixel values. So let's upload that code then to our Arduino and see if we can get this calibration software running. So that's our first X position then. So if we then touch that, it should then move across to our second X position. If we touch that, we should now be able to move the square around the screen. And you can see there that it's actually following our stylus quite well. You can see there's a little bit of glitchiness as regards the readings. And again, that's just part of the way that the screen's working. Again, these are quite cheap screens, so you know, we're not going to get absolute precision with these ones. But you can see there that now that we've calibrated that, you can see that our translation code between my stylus position and the screen XY coordinates is pretty good. Okay, so that all seems to be working okay. So let's come back across then to our code. Now that we've got our LCD screen working and our touchscreen working, we can start to create various user interfaces using this touchscreen idea. So I've got some code here which will just generate a simple button, and we can then detect whether we've clicked the button or not. So again, you could use this to control various projects and so on. And again, when we write the breakout game, we'll see that we're using that to control both buttons and then the bat itself. So really what I've done, this is just an expansion of the code we just had before, but I've created a little button class. Now there actually is a button class built into the Adafruit library, so please do have a look at that to see how that works. But I'm just really creating a very simple one here so we can see the general idea of what you need to do. So the button itself has got obviously an X and Y position on the screen, a width and a height, and then some text on the button itself. If you're not familiar with working with text in the Arduino or the C++ system, again, you need to have a look at how that's done using character arrays, and of course then getting into the idea of C++ pointers. But again, that is another topic, to be honest. So we are just creating here some simple methods within this. So we have initialize our button, so we're setting up its position and passing that in then. And that then really just sets up the button, and then a render function which will actually draw the button on screen. And I'm really just drawing a green rectangle with some white text inside it. We then have an isClicked method, and this is going to return true or false. So I'm going to use one of these screen point objects which we set up in the last block of code. So that really just encapsulates an X and Y pixel coordinate. So really just checking if that supplied X and Y coordinate is actually inside our button area, then we're going to return back a true, otherwise we're going to return back a false. So that will let us know whether, when we've detected a touch point, that whether it's actually inside this button and whether the button's been clicked or not. So the rest of it really then is exactly the same as we had in the calibration function. That's all the calibration stuff there. We're then creating a global variable to hold our button. And then inside the setup function, we are initializing the button to be this size with just the words "click me" inside it. So inside our main loop then, so again, we're going to do the actual touching bit inside the loop. So we're creating a screen point object here to capture that screen point values. So we're checking then. So if the touch screen is touched, if it's not being touched, we're just simply in effect writing over where we're going to be putting up a message. But if the touchscreen is touched, then we're getting hold of that touch point, converting it to a screen coordinates. We're then checking, so we're asking that button object, have you been clicked? So again, we're calling it isClicked method and passing in the screen coordinates. So if it has been clicked, we're going to write a little message saying clicked. Otherwise, we're going to overdraw where that message would appear. So basically, what this will do then is when we run it, if we touch the screen and we're not inside the button, we'll just simply get nothing appear on screen. If we touch inside the button, we'll get our message clicked. So let's upload that into the Arduino and see what we get. Okay, so that's uploaded, and we're now running our calibration function. So if I just calibrate the screen, and there we have our button appearing. And again, we can play around with making that prettier and aligning things properly. But if I touch over here now, nothing happens. And then of course, if I click on the button, we get our click event being seen. So that then gives us a way of producing some nice user interfaces for our Arduino projects, where we can put up buttons and little sliders and so on. And again, it's just a matter now of using this touchscreen function and monitoring clicks and then writing little code to produce our user interface items. And as I say, we'll be doing that a bit more when we come to do the breakout program, which I think will be the very next video. So we can now use the touchscreen as an input device for our Arduino. So we've really got everything we need now in place to start writing a bit more software and perhaps a game. So if you've been following through on this series, you'll notice that I've been using a Breakout or Arkanoid clone as a bit of a demo program. And that's really what we're going to tackle then in the very next program. So we're going to bring together all of our graphics, our touchscreen, and a bit of C++ programming and bring that game back to life again. So, look forward to seeing you in the very next video. Have fun making, and I will see you soon. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics, and gaming projects. All the links are in the description below. For more games programming, electronics projects, and retro gaming, please make sure you like this video, subscribe to my YouTube channel, and visit my website.